This is part 2 of section 4.2. Now we're going to start talking about the actual trig functions of real numbers. So we have here an image of the unit circle, and I have a number line right here, and we're going to call this the t-axis. So what we're going to do is imagine taking this t-axis, and we're going to place it as a vertical line that just is tangent, meaning just barely touches our unit circle at this point. So I got these images from your textbook. I am not good enough to create these myself, but we look at this. Okay, so we have this number line right here placed tangent to here. Now what we're going to imagine doing is we're going to take this number line up here and we start bending it around the circle. So if we're bending in this direction, what this ends up doing is it ends up measuring the arc length of our circle. So we're bending it around and it looks like this. Remember, if we're moving in this way, we're talking about positive angles. These are positive going this way. And also, if we start measuring it in this way, if we start bending around the bottom, our negative answers are going over here. So this actually is going to correspond with angles. We're not talking about that direction yet. We're talking about arc length, but these are going to be very closely related. Okay? So what we do is that for every real number t, every point on this number line, it corresponds to a point somewhere on the unit circle, which is xy. And we're going to call this point the terminal point associated with the number t. Okay, so just the way this is drawn, if this is 0.5 and that's our t value, then this point right here is going to be the xy value that's associated with it. That's going to be the terminal point associated with that. Now, if our arc length is greater than 2 pi, so that would mean we're going around more than once because the distance all the way around the unit circle is only 2 pi. Or if it's less than negative 2 pi, that means we're wrapping it around more than once in this direction. Now, what that means to us is that we can have a terminal point associated with more than one t value. Okay? Now, because we're going to define our trig functions in terms of the unit circle, these are often called circular functions. They are based on a circle. So we're going to talk about our 6 basic trig functions. We have sine, which is S-I-N-T, cosine, C-O-S-T, tangent, tan-T. Okay, these are the 3 main ones and the ones that you will see on your calculators. Doesn't matter which kind you have, you're going to see sine, cosine, and tangent on all of them. Okay, now our others are cosecant, which is CSC, secant, which is SEC, and cotangent, COTT. Okay, now our unit circle definition. Okay, so t is a real number, so it is some sort of arc length, and we are wrapping that t-axis around our unit circle, and we have an associated point on the unit circle, x and y. Then, sine of t is defined to be your y-coordinate. Cosine of t is your x-coordinate. And tangent of t is the ratio of sine to cosine. It's y over x. And of course, x cannot be equal to 0 because we're still not allowed to divide by 0. So these are our main ones. Over here, our other 3 is cosecant is defined to be 1 over y, which is the reciprocal of sine. Secant is defined to be 1 over x, which is the reciprocal of cosine. And cotangent is x over y, which is the reciprocal of tangent. Okay? So we talked about them being reciprocals, and it's going to be important for you to remember this relationship because once we get to the point where calculators are needed, you're going to discover that you can only compute the left-hand functions. Like I just showed you, we have the buttons for those three main functions. And you are going to need to remember to take the reciprocal by yourself to calculate cosecant, secant, and cotangent. Now, on your calculators, I do want to point out one little thing. On all of these, you'll see that sine, and you'll see this sine -1. And on this one, it's above it as well. And here, they serve the same on the same button. You'll just have to hit the button more than once. This s to the -1, all of these -1s here, that is not reciprocal. That is a different kind of function altogether, one that we'll learn at the end of chapter 4. To take a reciprocal on your calculators, you're going to look for either this button, which is 1 over, or on others, you're going to see x to the -1, maybe, and that will take the reciprocal for you. This is also x to the -1. That's going to be your best friend when calculating these, okay? One good way to remember how the two pair up, which ones are reciprocals of each other, it is simply that each one requires a co. So cosine already has the co, so it's the one that goes with secant. Sine needs a co, that's cosecant, CSC. And then tangent and cotangent, those are the ones that are easiest to pair together. Okay, we're going to be coming back to all of that. So in particular, sine and cosine. Since we have defined sine t to be y and cosine t to be x, then I can label a terminal point either xy, or I can label it cosine t, sine t, and it is exactly the same thing. This will give you the point associated with an arc length of t. So let's use this. If the point 1/2 square root 3 over 2 is a terminal point on the unit circle that corresponds to the real number t, find the values of sine t, cosine t, and tangent t. Sine t is the y value, cosine t is the x value, and tangent is defined to be y over x. So this should be fairly easy. Our sine value, sine of t, is our y-coordinate, which is the square root 3 over 2. Our cosine value, cosine of t, is our x-coordinate, which is 1/2. Okay, and then tangent is our y divided by x. So tangent of t is our y-coordinate divided by our x-coordinate. And you could, of course, write it as a complex fraction with a fraction within fractions, but it's usually easier just to think of it as a true division. And then when dividing fractions, you keep it, change it, flip it, which gives you your tangent value of simply the square root of 3. All right, now we're going to do the same type of problem, except we are asked to find secant, cosecant, and tangent. Since these are reciprocals of our three major ones, I'm going to find these first, and then we'll take the reciprocal. So sine of t is our y-coordinate, so that is negative square root of 11 over 6. Our cosine is our x, so that's 5 over 6. And then tangent will be negative square root 11 over 6 divided by 5/6, so that's the same as multiplying by 6/5. So our tangent value is negative square root 11 over 5. Now let's find these. Sine of t, its corresponding reciprocal. Remember, everyone needs a co, so this goes with cosecant. and I take the reciprocal of this, which is negative 6 over square root of 11. Now these, like I said before, they are almost always rationalized, which means you multiply the top and bottom by that denominator. And it becomes negative 6 square root of 11 over 11. Cosecant, its reciprocal is the secant function. And so I get simply the reciprocal of 5 over 6, which is 6/5. And then the reciprocal of tangent is cotangent. So this would be negative 5 over the square root of 11. And you rationalize this to get negative 5 square root of 11 over 11. Now, some calculators will rationalize for you, which is really nice. If I want to enter negative square root of 11, negative square root of 11 over 5. And then if I want to take the reciprocal of this, so I hit secant and then 1 over x, it does it for you. This calculator and this one will do it for you. The graphing calculator will not.